signature verification, automated, and then you have speech verification, which is based on your voice. You'll be other than that, you also have this gait verification, which where the person walks. And then what is also interesting is that the way you type on your computer laptop, the way very unique. I can try to mimic, but it can still be very unique. And then there are some other kind of biometrics which are a bit more invasive in the sense that they're not visible to them. For example, the vein that I have in my finger. And then you have the iris, which is visible, but you want to get the intricate pattern. Not in visible spectrum, but mostly in the NS. That is not entirely true as well, because most recent works have shown that for some population and then there are also very recent advances. Some are also interesting. There have been talks of being very unique. Audio knuckle patterns are then recent folks have also talked about art forms. So these are all like very new and upcoming areas, but they might not be usable in every day. I cannot get trained with a person. Okay, so before we consider doing any kind of biometric verification or biometric, there are some factors that. So these factors are, for instance, the universality, the collectability. So in the rest of the next 5-6 days, will become more attack resistance on how generative AI can be. But let's take a simple look at each of them. When we first talk about the universality, we assume that everybody character is very well. There are some of them. For instance, monozygotic, they tend to have same weights. If you exclude some of these corner cases, then universality faces in. And then we have distinct. Are the two persons sufficiently different in terms of characters? Now, unimodal solutions are possible, which means that I can use the fingerprint, but sometimes maybe the faces are very similar. So in that case, I can create what we call a multiple. And then permanence. This is also very important aspect, because as we progress in the age, we change over. So there should be a certain amount of permanence. That is the whole reason why. And then every 10 minutes, it's usually lesser than that. I think it's 1 year in the first year and then 5 years. So that means that there is varying over the period. And one of the characteristics that is varying over the period of time, unless you have extended periods or the accident. And then collectability, I could have the world's best biometric quality, which could be like deep test, but if I cannot access it very more usable, in the sense that I walk through a corridor, my face can swipe my fingers and capture it. But the other part might be better. So we need to also consider. And then we have the performance. The performance is about, you can have some of very good. They can be also lower. For instance, let's take hairstyle. So many of us would have very similar. So if I'm using hairstyle as a unique characteristic, that's not very good. Of course, it can go as a metadata, as a addition of unique. And then comes the other aspect, which is performance. The performance is critical in parts, even in small setup. From my go for my smartphone, I should be able to open less than don't have files. And then when we can scale it up to a bit larger, let's say for instance, what are we talking about? We're talking about 1:1, 1:1.5. So we should be awesome. So whatever the system that you're developing, it should consider that speed is, and the resources are required, which is required to just are just to make one compile file. It's an inter. And then when we talk also about the, we also have the specs, which is all good. And then what do we mean by should not be same active? If I go to the other part, after that, I need to. And then comes the acceptability, which is very interesting. But to begin with, assume that we are in a situation where we are, let's say, I'm staying in America. That is if you ask for 10 very from a fingerprint, and it's not very well. I mean, if you're influenced, you probably will. And the same thing also can be stuff. The authentication system aspect in addition to it take care of attack. So attack resistance is although we use something called as spoofing, which is mostly common. That's what presentation back taken. But spoofing can be a bit more sense that I can try to somebody else more. That means the center should do classify or detect between the genuine voice of mine. And that's not only for the voice, it's also for the face. So for face recognition, we have images of you have Facebook, Instagram. And every single time I get to Facebook, the Facebook can just take it, and then I can print it out. So the camera doesn't really know actually. So although it cannot be solved fully, but there are ways to attack. Okay. So these are some of the aspects that we will start considering for the rest of the course. But before we get there, I just want to use some. Whenever we are doing this kind of analysis, we try to put the paper written by Professor Jain, and it still looks very good. See that some of these are extremely good for so they kind of vary across all the. So the idea here is that whenever you are trying to implement any biometric for your own use case, you need to make a detailed analysis of all this, what is positive, what is negative, what is not. So if you can see from this simple chart, you can clearly say that the body order is. Then two modalities that some of them often fail to stay at. All right, so I just that. So the utilization part, what you want to look at is that four other. One is security with convenience, which is typically measured in biometric. I think we have a lecture on. And then it should be efficient, and then comes the other part, which is quality, which is the reliability of that aspect, and the objective of the. And again, in some cases, if you look at the left side, here we have two different applications. Identity access So if you are talking about the identity, what you want to achieve, high security you want to achieve, high convenience, um, good efficiency, but when it comes to you really don't care so much, right? So you focus on different things. You focus on the security and then you focus on the efficiency. Why do we say about the efficiency and the security in this case? Let's say, for example, you have a very simple system, surveillance. Surveillance is a system that is simply installed somewhere and then you walk. So there you do not necessarily have an interaction with it. So you don't want to do that. So what you want is you want the system to be able to detect people, who they are, what they're doing. So in addition to what we did in the previous case, looking at the characteristics, we should also look at the domain. And this is when these things, so we say, okay, if this system is given for opening your phone, then we probably want security, convenience, that we can quality. But if you're talking about law enforcement, then it's a different case. Then we are talking about high security and highly. And while we are also implementing this authentication, we should also be a bit more aware of other aspects, such as identity and access management is typically. So if you want to cross a border, you're going to be cooperative with the border guard, unless you really get this. And then there is also this uncooperative, where you're trying to monitor a particular area, monitor a particular location. And then there are also two other modes that we come. One is to over, and the other one is to over. When we say about over, I know that you are going to cross the system and you are being informed. So then you know that, okay, I need to give my face, I need to give my fingerprint, and you're trying to be asked for a figure. Typically when you go to do a bank transaction on your mobile. And then covert is typically when the subject is when we say unaware, it might be there is a notice probably in the recent days where they say that this area is by surveillance camera, but it might also be that in the older days it was not. So you are doing the identification very quickly without the subject aware. And then we also have this two other aspects, which is acquisition aspects and authentication, explicit acquisition. In the case of the explicit acquisition, we need the user to interact. A common example is that if I ask you to give your face picture, you will interact with it, right? You take off your mobile phone and then look at it, then give a picture and then get it. And the implicit acquisition is typically something that you do not really need that. You don't need explicit. For instance, you just pick up your phone from your pocket. There is a particular set of movement that you do all the time, and this movement itself is sufficient for you to be detected as so we have this explicit acquisition, this type. Now these aspects I'm discussing because tomorrow when you're going to implement your own biometric, you'll be able to, okay, should I need the user to track it, or do I not need any? I can visit. Okay. Let's now get into the aspects of real interface. Okay? But just to get started with, any kind of biometric system typically starts with acquisition device, which could be a camera, which could be the way you type on your laptop, and any other way you sign your signature. Right? But irrespective of all those things, the very first thing that you're doing, you're trying to get the data. And then we have the next aspect. In the case of face, which means the object of interest. So if I take a picture here in this, and if I'm not interested in identifying any of you except then I would be only detecting that person, right? So I need to first localize every single face in this whole classroom, and then I try to put it. And then once I have extracted that, at least in the older days, even in the modern system, they tend to do this, is to align the face. Why do we need to align the face? Because sometimes people might be off-handed. Then you want to try to align it so that the next process, it's not a mandatory requirement, but it makes the process, subsequent process easier. And for the most modern system, not really to do that, so it can be trained to all those things. Okay, so once we have done that, then we extract the features. The features are anything that is coming from me to something that is more meaningful. So what do I say more meaningful for us? For instance, if I extract the features from apples and bananas, a classical example, and you know that for apple it's red color, rounded shape, that is right. So that's the same exact thing that we do. In the case of face, we extract the features that mean for identifying and separating. And then once I have that, maybe I have a database of all the images with me, then I can verify it. Identify. I'm interchanging using the word verify and identify. I'll explain that differently. But the whole idea is that you've got two features and if you have a database, then I can know that, okay, this is the first picture. If I don't have that, I can say that this subject is not. Okay, so now put all of these things together. So what are you going to get? You're going to get something for that record. So at this point of time, you can kind of separate out pipelines. So the first pipeline is detect path, where I'm localizing the object, and then rest of all this come under a classical paradigm, which is also for our. Okay. So if you take a practical scenario, how does this happen? So you have a face, and then the face image is cropped. And now again, look at this cropping here. So I don't really care about what shit I'm with. Here I'm having only crop the area that's relevant to the task. So this is again a big change. And then in the plain domain, like the extract feature, completely unreadable by time. Then I follow by extracting the features. In this case, it's a histogram. Like that picture that I have, and so on. I get the histogram, and then I can for putting it in. While I'm saying that this is a simple process, what is also important is that here at this point of time, I'm really not confident in the practical scenarios when you implement an authentication system, you should never raw features. The reason being, if I get access to the raw data raw features, then I can do multiple attacks, right? So I can simply compromise the database. I can invert the features into the face image and so on. So if you are interested, just set aside some time for that. But remember, in your practical implementation, never put this as it is, and forget even putting the face image. No raw data should be on it. They should be protected. Okay, so now if you look at this, right, so you can see that, okay, this can be somehow separated out in top of those components you put in it, and this image can be coming from any kind of. So then something the authentication system, the integration part of interesting, because your camera, your mobile phone camera, there, or a camera that is set up, or infrared cameras and so on. Now, this is the common scenario, but what happens in the moment is that at least after 2014, things have changed radically. You do not really need to do anything there. So what happens in this case is that all this thing that I spoke about so far is redundant. Redundant in the sense that you do not need to really identify object, you do not crop the face and then send it. But you can train a network which passes the image through multiple layers, and then at the end of the day, you have identity person or not. Um, there comes some very interesting architectures. This, whatever I've called blue components here, it's exactly the component that you can see in the modern architectures, such as the ResNet, whatever the network is. Some of them come with some advantages, some of them don't. But any generic architecture can be adapted sometimes. And then you also would want to identify these two people, right? To how do I identify the difference? There comes the idea of intelligence force, which is also used as a loss function. And then you can engineer it so that I have a comparative. I have a comparison between three different people, and then I can say, okay, these two images are similar. That's a triplet loss. And then we just put it as an angle, try to optimize it in terms of two vectors. Linear algebra concept where you have two vectors and you try to measure the distance between them. So then comes out like after. Okay. And then now most modern systems, as I told you, it's like most of the components are excluded now, right? In the previous diagram, I was showing you that detection, feature extraction, feature comparison, and so on. And we do not really need that. We all go back to capturing the phase A, putting it to a CNN or any transform, and then extracting a vector as compact as 128 dimensional vectors, then doing a cosine similarity, and then so you are getting it. Okay? So the whole, in the last 10, 15 years, what has happened is that the extensive pipeline of authentication system has been compressed to one simple. Okay, now what makes it different if I'm considering fingerprint? So it's exactly the same pipeline, except that I have some small change. Now these small changes are very subtle, right? So first I capture the fingerprint, and now when I'm capturing the fingerprint, what am I doing? I'm trying to the optical sensor, whatever. And then once I get the picture, typically in the scenarios of fingerprints, I don't know how many of you have noticed when you're trying to give your fingerprint again, there are latent fingerprints from previous. So which means I might confuse my fingerprints with that one. So the very first thing that you want to do is to enhance it. And this enhancement is very similar to what we did in faces, right? I try to align them, which is also a kind of. And then once I do the enhancement, then here we don't extract typically the texture features like I told you before. If you look at what is called as defined, if we talk about it tomorrow, I think there's. And then once I extract the minutiae, it is nothing but a set of features, and that set of features are compared with one other feature, then we have a map, or we have a company. Okay? So the pipeline of the authentication remains very similar irrespective of modality. And then these things I will talk about it tomorrow, but just as an additional concept here, what you should also remember that okay, so just to go back here, right? But you just ignore that. Whatever I showed you here, the minutiae template is typically your positions on your fingerprint, which is x, y, and theta, where in the image is x and y, particular point, and what is over here. So you could also replace it with a modern system, deep learning. You can just simply put a CNN, and that can also extract very significant. That is what we call as temporal textual-based descriptors. And then we have some other challenges. Just to give a comparison between two authentication. First authentication, we were talking about maybe lighting, the face recognition system. But in the case of fingerprint, the noise changes. Nothing else changes, but the type of noise that they are dealing with, that changes. The sensors are different noises. And then the variation in terms of the images might be different. But if that then 7% will, then it's very different, right? So something very different. The others, the autonomous, very low variation. And then not so different from face recognition. These systems are also very, very powerful. And here probably it's slightly easier to conduct a presentation attack because most of you are using coffee cup, most of you are using water bottle, then you be able to from that. So all you need is that you extract the fingerprint from that and then try to create a gummy fingerprint of that. And this gummy fingerprint creation will cost you less than simply go to the supermarket, buy all the gels that you use for cake, jelly, and then get that. So the fingerprint presentation attack is quite even bad in the case of the radio adversary. These or generative AI, they can create very for okay, so the commonality is the same. So what I'm trying to establish is that whether it's face or your fingerprint, the pipeline remains the same, attack remains the same. The only thing that data that you say, feature that is that's all. Okay, and then now we should be talking about whenever I'm implementing an authentication, then I typically have considered three different cases. First case being identification versus verification. Close-set versus method, then core-based decision making. Core-based decision making, that is very common these days, not common as it doesn't stand out distinctly. But verification and identification is something that I want to a bit of. So let's assume I have a passport. I go to the police officer and then I tell that this is me, I'm Kiran. So all he's going to verify is that this is actually Kiran by looking at the passport. Right? So I'm claiming an identity and then the identity is being verified. So this is typically the verification. And then identification scenario is slightly different in the sense that I have all the people that are present in a certain population, in a class, in a community, enrolled in the data set. That means every person has a name, person has an age, identity. Then what I need to do is I simply need to walk into the corridor and then I select it. If I'm present in that. Then what are we talking about? One is to n number of. So identification with n and verification is 1:10. Right? Okay. And then we have also the closed set and open evaluation, right? So this is somehow very closely related to identification. Since that if I know all the people that write this particular course, then I have all of your data with me. Then I'm doing closed set. So if anybody from outside comes into it, then I know that this person is not in the class. Then all I'm going to say is that he's not in the class. I'm not going to tell who that person is, but I'm just going to tell that this person is not in this person. So that is like the most generic definition. And then comes the problem here, right? So what happens if I'm developing an authentication system? Let's say, for example, I'll say triple ITD is biometric, and that training algorithm based on all the student targets. But who are their customers? Maybe their customers are somebody else. Their customers is the city corporate. But those people are not in that particular system, right? So how do they scale it up? From training the system from people sitting here to something that is usable out. So that's when we talk about the opening of code by simply eliminating the last layer, which will display on, and then using it as a simple feature. Okay. So once I extract the features, then I can use it for comparison, which using a cosine difference function. Okay, so this is typically the case, right? So I have in the verification scenario, I have a probe, and then I have an identity whenever I'm saying a probe, which is nothing but every time I'm trying to do some interaction with, have some interaction. So when I'm going to ask, okay, listen, my name is Kiran, can you verify me? That's when we call it as verified. And then you have an addition which says accept all. But in the case of the other scenario, really not going and claiming Kiran, I'm just saying I'm walking in, saying please verify. And then if you look in n number of people that are in the data set, and then search through that, it's accepted or yeah. Two fundamental differences. Any biometric. Okay, so this, I don't think I need to give a more detailed introduction, but I think you all get an idea that, okay, the system has something that is doing the comparison, and then you have the and you can also kind of look at the trends. The trends have been changing very extensively. We have gone away from passport systems to more digital passport systems. And these digital passport systems are typically what is called as digital traveler credentials. Is there anybody that has known about this? Okay. Okay. So the whole idea is that we are taking the passport and then we are eliminating the physical document and putting them on. Right? So then you can have all the system that you interact with. You can interact with them on the passport. Okay. Just to have a common understanding. There is also one other thing that we need to talk about. We need to talk about search and deduplication. We are talking about verification when we are saying, are you who you are saying to be? And then the answer is typically yes or no. And then there's a identification. They're asking who or what are you? And then we would say, okay, this is, let's say, Kiran. And then the third case, we have the search and duplication. Now, search and duplication was a very critical problem in Aadhaar when a system was implemented, the whole authentication. What exactly happened during that time is that there were people who were, including me, I was traveling from one city to another city, so I could enroll in both of them. So which means there are two entry points. And now what you are doing is that you are trying to search the entries within the database. Have an external reference, but you have some reference which you use as saying, okay, first entry, all the other entries, the second entry, all the other entries. Okay. So this is not very often that you hear about this term, but when it happens, it's very critical. All right, so where is the intersection of all these things? So there is always this verification and identification that are kind of intersecting quite nicely. And then you have the intersection between the search and the identification. And at the same time, it might be a small interaction in all the three cases in special setup. Okay. So any authentication that you're implementing will have some component of all the. Okay, and then there is some very common terms that use this aspect. For instance, if your identity is being claimed and the data is typically stored on a token or in a data. Right? So you have your smartphone and then your image is stored in the smartphone and then you're giving an image to it. In the case of identification, it could be a bigger database. Now we are not talking about your smartphone, but we're talking about a bigger database like Aadhaar. And then there is also this other situation where when we end up with open set identification, then we need to have additional verification. For instance, if I'm saying that, okay, if I'm enrolled in IIT, then I'd say that, okay, this person is not identified, then the people will still be just depending on who. So that comes additional. And then on the other side, you have multiple verification when you're doing search. And typically, this comes with uncooperative data subjects, and conditions might be extremely adverse in the sense it might be a night light setting where you do not completely see the person. And so then comes the idea of authentication system, which has to pay attention to the enhancement part, the first part. Okay, just before we start implementing our own system, what I want to also show you here is that I think you'll have a very detailed lecture about this tomorrow. But just to give a quick introduction to that, what we are trying to do is that we have this particular image, which we call as reference, which is stored on your device. Then we have a template, or we have a sample that we call as test, or we call as probe, and then we try to extract the data from this. And then what we do is that compare them. Once we do the comparison, say that the score that we have obtained, is it greater than a particular threshold or not? Right? This again is something that we learn. I think tomorrow morning we'll have an introduction to that. Once you have that introduction, you can go back and read it in this problem. But the idea here is that the S can be something that is similarity, is cosine similarity, how similar these two vectors are, or it could be dissimilarity, how far the two vectors are. And then now if you put it back into the phase recognition system, it's exactly the same pipeline. Only differences that can happen in your authentication that you might not always be getting this kind of high quality data, right? You might be getting something that's really bad quality data, which is of your passport. It's very small in images. And that means there is a feature that is that here. So we need to have some amount of tolerance. Say these two vectors, although they are slightly different, they're coming. And that's when we are talking about this threshold here. And this is typically a system that is from the data that is not present in the deployments. So in the authentication system, you can always go back and fine tune that one, but you will always start with the basic point, which is outside of that, right? Just because, for instance, if you want to implement a recognition authentication system for this class right now, I cannot really determine because my system is trained on some of it. So I determine the threshold there, but I can fine tune it later on. I can say, okay, you know what, for this class, the threshold should not be 0.5, it should be 0. Okay? So that flexibility. Okay, again, the common challenges here are also that I showed you in the previous case, bad quality data, and in the other case, it could be some other comparison, choose a different comparison. Maybe my images are always different in every setting. For men, it could be fair mustache, for the be makeup, different hairstyle, and so on. And that is one of the primary reasons why your templates are constantly updated. Right? When I say template, the features that we are updating. Okay. So those of you who are using iPhone, at least you must be noticing this. When you change your glasses, you do not really need to update your picture again. It simply adapts that one to the new picture. Okay, so that kind of should give you a reasonable introduction to the authentication system. And then comes also this fine-tuned models where you can say that, you know, if I know that for Kiran, the threshold is not always constant, so I can fine-tune it constantly because I have multiple templates, right? Every single time I have new data, I can say that the threshold should vary between this and that. Now, this is very subtle implementation level. Tomorrow, if you are having your own startup, then you know that this happens. Okay, any questions so far? Thing that you've been wondering for. Now we look at yeah. So that is just the features that are extracted and put it in different features. So just the features are okay. So now if there are no other questions, so imagine if you are implementing a typical authentication system, here you are talking about two different modalities. I'm constantly varying the modalities, but you can see that there are two different, slightly different appearances. So the first thing that you want to do is that you want to make sure that you are upon variability. The noise. For instance, here you can see that the eyelashes are kind of covering eyes, right? But here it goes. So I should be able to do that. I should be able to account for that particular. And then in addition to that, it also depends what kind of sensors there are. Are you using a smartphone which is iPhone, or are you using the smartphone which is from Android? So then your sensor noise will also change slightly. So that is the second. And then you have the third aspect, which is the feature extraction, where we are talking about, okay, where is that extracted feature? Am I using classical machine learning? Am I using some deep learning? And that will give me the features that are extracted. This is a vector that is R, and then here you are getting a vector that is X. Now R is not equal to X, that means that you have to have a threshold to click that. Okay, this is acceptable or this is rejected. Okay. Good. So that's about the ideas, and then you could just from the practical aspects, it's possible to store the images at this particular point after the sensor is obtained, after the normalization is done, or after the sensor is done. But what is recommended is not to do this thing, but only to do this. So only to take the only after the features are extracted. Okay. And then here is the place where we should also establish some terminologies. Some of the terminologies, for instance, here are that whatever is captured from the top area is called sample, and then control. I see the reason why we say that not be stored on the database as it is, because this can be compromised, but this can be stored because it's simply a set of features, a set of numbers, and these numbers can be. Okay, so it's everything that you do in a biometric system is sample. And then you have a slightly more complex model. So what typically happens is that practical scenarios, all these things are happening in the training samples. So these are your training samples, right? So which is completely different from the sample. So you extract the data and then train a module. You train a module for normalization, you train a module for feature extraction, then you train a module. Once this is done, this is all offline process, all the things that are same before, and then you take the bottom part, say that, okay, now it's deployed. So remember, if you're using your own face image for training the face recognition, not do the same for testing. So that's some practical aspect. All right. I think at this point of time, I'll stop this one and then try to open up